Hi children, how are you? Hope you are doing great. Welcome to Electron Chemistry Center. In today's lecture, we are going to discuss a method to find hybridization. In previous lecture, we have learned about types of hybridization, what is hybridization, what are the conditions of hybridization, what is the need of hybridization. These are the concepts what we had discussed in the previous lecture. This method is especially useful for competitive examinations. And let's see, there are two shortcuts or two methods to find hybridization. Let me discuss the first method, then I'll go to second method. First method to find out hybridization in a short way is electron pair method. Electron pair method, in which P is equal to half of V plus M minus C plus A. This is the formula used to calculate used to find out the hybridization. Let me explain you the terms involved in this formula, where P is equal to number of electron pairs, where V is equal to number of valence electrons on central atom. M is equal to number of monovalent atoms attached to central atom. Number of monovalent atoms attached to central atom. Monovalent atoms in the sense like hydrogen, chlorine, fluorine, bromine and iodine. These type of atoms are called monovalent atoms. Right? Its valency must be equal to 1. If divalent atoms are there like oxygen, in such cases this M can be taken as 0. If monovalent atoms are there, then only we need to consider N, where C stands for charge on cation. If plus 1 is there, C value will be equal to 1. If plus 2 is there, C value is equal to 2. Similarly, A stands for charge on anion. Like how many negative charges are there? If minus 1 is there, then A value will be equal to 1. This is the terminology involved in this formula. Now let me tell you, or let me explain you this formula with the help of an example. First example we are using. Before that, P is equal to number of electron pairs I told you. For suppose if P value is equal to 2. If P value is equal to 2, in such cases hybridization is sp, 1 plus 1. If you got P value is equal to 3, in such cases hybridization is sp2, 1 plus 2. If you got P value is equal to 4, in such cases hybridization is sp3. If P is equal to 5, in such cases hybridization is sp3d, 1 plus 3 plus 1. If P is equal to 6, hybridization is sp3d2, 1 plus 3 plus 2 is equal to 6. If P is equal to 7, hybridization is sp3d3, that is 3 plus 3 plus 1, which is equal to 7. Right? Like this we can find out the hybridization. Now let's start with the examples. Example 1, BeCl2. Let's see how can you find out the hybridization present in BeCl2. What is the formula I told you? P is equal to half of V plus M minus C plus A. half of where beryllium valence electrons equal to 2, number of valence electrons. Chlorine is an example of a monovalent atom. How many monovalent atoms are there? 2 monovalent atoms are there. So it is 2 plus 2. No charge on cation, no charge on anion. So it is C is equal to 0, A is equal to 0. 2 plus 2, 4. 4 by 2, 2. So P value we got 2. Hence hybridization is sp hybridization. Right? This is the way how to find out hybridization in a short way. Similarly, let's make a look on it. Second example, BF3, boron trifluoride. Boron trifluoride, what is the formula? P is equal to half of V plus M minus C plus A. So, half of valence electrons in boron are equal to 3. 1s2, 2s2, 2p1. No? Outermost electrons are 3. Monovalent atoms are also equal to 3. Charge on cation 0, anion 0. 3 plus 3, 6. 6 by 2, 3. So, which gives you sp2 hybridization. Why? Because P is equal to 3. Hence, hybridization is sp2. Now, let's make a look on it with a common example, that is methane. Methane, if you observe, P is equal to half of V plus M minus C plus A. Valence electrons in carbon 4. Monovalent atoms are 4. Charge on cation 0, charge on anion 0. So 4 plus 4, 8. 8 by 2, 4. Hybridization is sp3. This is the way how to find it out. Now similarly, if we take one more example, PCl5, phosphorus pentachloride. P is equal to half of V, valence electrons around central atom, phosphorus, 5 valence electrons. Monovalent atoms are 5, charge on cation 0, charge on anion 0. 5 plus 5, 10. 10 by 2, 5. P is equal to 5. What is the hybridization? sp3d. Similarly, if you go for one more example, SF6, sulfur hexafluoride. What is the formula? P is equal to half of V plus M minus C plus A. Half of valence electrons around sulfur, 6. Monovalent atoms, 6. Charge on cation, 0. Anion, 0. 6 plus 6, 12. 12 by 2, 6. If P value is equal to 6, hybridization is sp3d2. Similarly, if you consider another example, IF7. IF7, P is equal to half of number of valence electrons around iodine. How many? 7. Plus monovalent atoms, 7. Fluorine. Number of fluorines are equal to 7. So charge on cation 0, anion 0. 7 plus 7, 14. By 2 is equal to 7. If P is equal to 7, what is the hybridization? sp3d3. This is the hybridization can be given. Like this, we can find out the hybridization of any molecule if it is given based on electron pair method. I'll tell you few more examples here. Let us see xenon compounds, XeF2, xenon difluoride. So P is equal to half of number of valence electrons around xenon are how many? 8 electrons. Why? Because it is inert gas, right? 8 plus monovalent atoms are 2. There is no charge. 8 plus 2, 10. 10 by 2, 5. If P is equal to 5, what is the hybridization? sp3d. Similarly, you can consider one more example, XeF4. That is xenon tetrafluoride. In xenon tetrafluoride, what is the hybridization? P is equal to half of 8 plus number of monovalent atoms are 4, charge on cation 0, charge on anion 0. 8 plus 4, 12. 12 by 2, 6. Hence hybridization is sp3d2. Similarly, you can take one more example, that is XeF6. XeF6, P is equal to half of V plus, V stands for valence electrons, around xenon, 8. Monovalent atoms are 6. No charge on cation, no charge on anion. 8 plus 6, 14. 14 by 2, 7. So if P is equal to 7, in such cases, what is the hybridization? sp3d3, right? So these are the examples you can give it for xenon compounds. I'll give you few more examples for ions. When they have given ions to you, in such cases, how do you calculate the hybridization? NH4 plus, it is a cation, positively charged ion is given to you. In such cases, let us say P is equal to half of V plus M minus C plus A, half of V, valence electrons around nitrogen. Valence electrons around nitrogen, how many? 5. Plus hydrogen, that is monovalent atom, so M value will be equal to 4. Minus charge on cation, here one positive charge is there, so you will get minus 1. Plus anion, there are no anions, no negatively charged ions, so 0. 5 plus 4, 9. 9 minus 1, 8. 8 by 2, 4. If P is equal to 4, what is the hybridization? sp3 hybridization. Now similarly, you can take anion also. If you take anion, what will you get? Let's try to understand with the anion. SO4, 2 minus. They will ask you to find out hybridization of sulfur in SO4, 2 minus. So P is equal to half of number of valence electrons around central atom. Central atom is sulfur, that is 6. Plus monovalent atoms. Here you need to identify monovalent atoms are not there. Why? Because oxygen. Oxygen is an example of a divalent atom. As I already told you, whenever monovalent atoms are not there, if divalent atoms are there and trivalent atoms are there, M value can be taken as 0. Minus charge on cation 0 plus charge on anion is there. So that is 2. You will get 6 plus 2, 8. 8 by 2, 4. So hybridization is sp3 hybridization. Like that, for ions also, this formula will be useful, or the shortcut is useful to calculate or to find out the hybridization. And one more example I will take it. BrF5, bromine pentafluoride. In that cases, bromine P is equal to half of valence electrons in bromine 7, as it is halogen. Number of monovalent atoms are 5. Charge on cation 0. Charge on anion also 0. As it is neutral molecule, there is no charge on cation, no charge on anion. 7 plus 5, 12. 12 by 2, 6. If P is equal to 6, what is the hybridization? sp3d2. This is the hybridization can be given for BrF5 molecule. Now, we have seen so many examples, right? Let's see the another method to find out hybridization in a short way. This is called steric number method. In a short way, it can be called as SN method. S stands for steric, N stands for number, which is called steric number method. In steric number method, you will calculate for steric number. Steric number is nothing but number of sigma bonds. Number of sigma bonds plus number of lone pairs around central atom. Or else the same formula, it can be given as number of bonded atoms. Number of bonded atoms plus number of lone pairs around central atom. How many lone pairs are there around central atom? That you need to consider. For suppose by using this formula, if you get steric number is equal to 2. If steric number is 2, then hybridization is sp. If you got steric number 3, sp2. Steric number is 4, sp3. Steric number is 5, sp3d. Similarly, you can use steric number is 6, sp3d2. If steric number is 7, sp3d3. So based on that steric number, you can identify the hybridization of a particular molecule. Let's make a look on it. With a simple example, I will start. But before going to the examples, you need to understand valence electrons. Like let us say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Lithium has 1 valence electron. Beryllium has 2 valence electrons. Boron has 3. Carbon 4. Nitrogen 5. Oxygen 6. Fluorine 7. Neon has 8 valence electrons. Not only these elements, the elements which are present in the same group, all these elements are having same number of valence electrons. Sometimes if they ask you sulfur belongs to oxygen group. In such cases, sulfur also having 6 valence electrons like that of oxygen, as you know that. Now let's move on to the examples. First example, BeCl2. If they ask you to find what is the hybridization of beryllium in BeCl2, you know that steric number, what is the formula? Number of sigma bonds plus number of lone pairs around central atom. Here BeCl2, beryllium can form 2 bonds. Why? Because 2 valence electrons are there. So it is 1 sigma, it is 1 sigma. So in that case, steric number is equal to how many sigma bonds? Their number of sigma bonds. Number of sigma bonds is equal to 2. And number of lone pairs is equal to 0. Why? Because 2 valence electrons in beryllium. All 2 valence electrons are utilized for bonding. In such cases, no lone pairs. Sigma is equal to 2. In such cases, steric number will be equal to 2 plus 0. What is the formula? Sigma bonds plus lone pairs. 2 plus 0 is equal to 2. Hybridization is sp hybridization. Right? I'll take one more example. Similarly, boron trifluoride. If I take boron trifluoride, boron, how many valence electrons are there? 3 valence electrons. So it can form 3 bonds. It can form 3 bonds. It is sigma, sigma, sigma. Steric number is equal to, that is, number of sigma bonds are equal to 3. Lone pairs are equal to 0. Why? Boron has 3 valence electrons. All the 3 valence electrons has been utilized for bond formation. So lone pair of electrons is equal to 0. Sigma is equal to 3. So Sn is equal to steric number 3 plus 0. 3. Then what is hybridization? sp2 hybridization. This is the another way to find out hybridization by the help of steric number method. I'll give you a few more examples. Let us take carbon dioxide. Carbon dioxide, carbon, and here oxygen and here oxygen. As you know that carbon has how many valence electrons? 4 valence electrons. What does it mean? It can form 4 bonds. Right? Here it can form 2 bonds and here 2 bonds. Total number of bonds are equal to 4. It is sigma, but it is pi and it is pi. As you know that in the formula you will consider only sigma bonds but not pi bonds. Sigma bonds are equal to 2. Lone pairs are equal to 0. Why? All lone pairs are utilized for bond formation. Sorry, there are no lone pairs. Why? Because all valence electrons are utilized for bond formation. So sigma is equal to, steric number is equal to 2 plus 0, which is equal to 2. Hybridization is sp. Carbon hybridization CO2 is sp. It's very simple. Now, like that you can take one more example. BRF5. Right? So bromine belongs to fluorine family. How many valence electrons will be there? 7. Bromine, it has formed 5 fluorines, no? 5 bonds are there. We are not talking about the shape. Generally, you can give it. So it is sigma. Total how many sigma bonds are there? 5 sigma bonds are there. But bromine has total 7 valence electrons. But here only 5 has been used up. Still how many are there? 2 electrons are there. Those 2 electrons can be considered as a lone pair. Right? So sigma bonds are equal to 5. Lone pairs are equal to 1. Right? It is one lone pair. 5 sigma bonds. So steric number. What is the steric number can be given? Lone pair plus sigma or sigma plus lone pair. 5 plus 1 is equal to 6. What is hybridization? sp3d2 hybridization for Br-F5 molecule. Like that, you can consider any example. Let us take XeOF2. XeOF2. In this example, find out the hybridization of xenon in this molecule. Xenon, as you know that, how many valence electrons are there in xenon? There are 8 valence electrons. Why? Because it is inert gas. So it can form 8 bonds. With oxygen, how many bonds it can form? 2 bonds. 2 fluorines are there. It can form 2 bonds. It is sigma. It is sigma. And it is sigma. 1, 2, 3, 4. 4 bonds it has been formed. 4 bonds it has formed in the sense, still 4 more electrons are there. Those 4 electrons can be taken as 2 lone pairs. Right? So total number of sigma are equal to 3. Lone pairs are equal to 2. So steric number is equal to sigma plus lone pairs. Sigma is 3. Lone pair is equal to 2. 3 plus 2 is equal to 5. If 5 is steric number, what is hybridization? sp3. We are not talking about the shapes here. Right? Shapes of molecules will be discussed in VSEPR theory only. Like, you can consider one more example. XeO2F2. If I take XeO2F2, xenon is the central atom. As you know that xenon has 8 valence electrons. It can form 8 bonds. With oxygen 2 bonds, another oxygen 2 bonds, 2 fluorines are there. Total number of bonds which is formed by xenon are 1, 2, 3, 4, 5, 6 bonds. But still how many electrons are there? 2 electrons. So it is sigma, sigma, sigma. Total number of sigma bonds are equal to 4. And lone pairs are equal to 1. So steric number is equal to 5. 4 plus 1. 5 in the sense, what is the hybridization? sp3d. That is the hybridization can be given. Now, if we take sulfur as an example. Sulfur compounds, let us take SO2. Sulfur dioxide. What is the hybridization of sulfur in sulfur dioxide? Sulfur is the central atom. Sulfur has 6 valence electrons. So it can form maximum 6 bonds. So 4 bonds it has formed. Then 2 electrons remains. 1 lone pair. It is sigma and it is sigma. Right? 1 lone pair is there. Total number of sigma are equal to 2. Total number of lone pairs are equal to 1. So steric number is equal to number of sigma bonds 2. Lone pairs are equal to 1. 2 plus 1 is equal to 3. Right? So if steric number is equal to 3, what is hybridization? sp2 hybridization. Now if we take one more example. Sulfur trioxide. Sulfur trioxide, how do you take here? Sulfur can form 6 bonds. All valence electrons of sulfur are utilized to form bond. So sigma, sigma, sigma. Number of sigma bonds are equal to 3. Lone pairs are equal to 0. All electrons has been utilized. So steric number is equal to 3 plus 0. Steric number is 3. Hybridization is sp2 hybridization. So this is the way how to calculate hybridization.